Hi, I'm Ryne Cheow, and I'm from NTUC Enterprise. So today I wanted to talk to you about some challenges that we have faced in any digital when we build application in the scale of enterprises. And a lot of the times we usually start off, building an app from scratch, which is the more exciting part of building an application. And we always know what we want to build for the year to come, for example, and we will start deciding the right architecture for the job to be done, and we started building off. The first year, probably the architecture is great and everything just works out fine. And as we build features on top of it, and we start to realize small little limitations around the existing architecture, and we will start building workarounds across the architecture or existing architecture that we have. So how do we solve this? We could practically keep the essence of the existing working teams in terms of how they work, in terms of styles, in terms of chemistry, and we try to preserve those as much as possible. In these scenarios, we could practically keep the essence of existing form teams, such as their working style and chemistry, and we can utilize this for teams to work in isolation based on some pre-aligned development rules, so that the team can focus on what's important for their respective business needs. So if we look at an example of what are the core components of very normal e-commerce applications, there are quite a lot of core components. If you can see, there is identity, which take care of authentication authorization, as well as the customer profiles. Orders, which take care of your purchases, which is one of the key component in an e-commerce app. And then there's also promotions, payment card, wish list, product search, as well as loyalty in some of the e-commerce applications in the modern applications today. And a lot of the times, each component, there can be a dedicated team for it. And for example, myself, I'm in the identity team. And there is orders team, there is payment team, product team, search team, and loyalty team. So how can we work in harmony together with so many different teams trying to achieve the business goals, as well as trying to work within the same application in, for example, this scenario? So to strike the balance between teaming and achieve a singularity of the application itself, we do have an ideation of architectural concept, which is, to start with an imperative shell, which encapsulates all these core components. And each of these core components will be functional core on its own. So how do we start off building this architectural concept that we just talked about? So first and most importantly, we will need to identify the relationships between the components so that we can make a decisions on, hey, what's required for most of the modules to be able to work on its own. For example, payment depends on authentication, and actually, if you look at it, most of the modules requires a certain kind of user authentication. So you can imagine identity as a functional core is more of at its basis as well. Yep. So once we start understanding the relationship, we can start looking at each of these singular functional cores and start understanding what's in them. So what's essentially in common between these functional cores is each of them may have its own user interface, might have its own way to access data. It could be different microservices that you've been talking to from product perspective versus from identity perspective. There is probably some common utilities or common entities like, for example, a very easy product entity that every functional call would have. And then there's also static resources like translation strings, like UI files. So these are the kind of static resources that we also have in common as all functional calls would. So now that we have identified what are the basic building blocks of a functional call, then we can look a bit deeper onto how should we be modularizing them in terms of architecture point of view. So we can start from the inside, right? As if I put myself in the angle of a developer from a single functional team, what's my focus? My focus would be on the feature that I'm responsible for. For example, if I'm an identity team engineer, I want to be responsible and I want to focus on building identity-related features and user interfaces, for example. And it was almost necessary to have these physical boundaries across logical partitions of the core. For solely the functional team's responsibility, for example, here, the product module is solely managed by the product team itself. And when it comes to taking care of bugs and implementing enhancements, the team would have full control over improving or rather work on the module itself. So like in the last slide, we have talked about a few key building blocks in every feature component or feature module, we call it here, right? So there are three major parts to form functional components, which are the domain logic, UI, and data exchanges as well. So they should be only written for what they are responsible for and nothing more. And each of them should be also be able to fully unit test by itself. So if you look at the diagram here, there is a radix on top, which I would give a bit more context later. And in here, there is UI flow and also module service provider. So if we look a bit deeper on the UI flow, basically there are two blue circles there that says EP, which are the entry points of the UIs where the most of the UI flows within the application remains internal. And if you look at the logic, the domain logic side of things, we should have use cases or services that helps us to talk to different repositories like API clients and local database, for example, etc. And then static resources are something that they can stand on its own. So if we zoom out a bit from the foundation itself, right? Sorry, not zoom out, but zoom into the foundation layer, which is radix here, by the way. So radix is essentially a base layer or foundational layer that provides most of the dependencies to the functional calls. So basically, functional calls can depend on radix as a source of dependency in case of how they talk to local DB, how they talk to API client. Radix would be able to help with that. How? So feature call interfaces in the last slide should be well protected through encapsulation to ensure these interfaces are only exposed in the application that are interested in. So as these features are going to carry out some of the common functions like calling APIs, storing objects, and navigating between user interfaces, we can start seeing that there's a need for this layer of dependency to heavily lift some of these common process executions. And this base layer would be able to provide, first, a development paradigm on the interface level, which means this will act as an in-between point for dependency injection, as well as from the application to the functional calls, which provides common operations such as interacting with remote API, interacting with your local secure keychain and local database, for example. We also should be able to type in our convenient extensions over here that can be shared across different feature modules. If you look a bit deeper onto Radix and what I mentioned about as dependency injection. So Radix here refers to the purple layer, which is the base, where the part of the app logic, for example, like database interactable, is sort of the interface defined on the base. Where on the application, if we're using Realm, you just need to define a concrete implementation of the Realm database interactor, which basically conforms to the interface. We can inject this instance through the interface into the base so that the feature modules at the basal level will be able to resolve the concrete implementation. This can be done either through, I think in iOS, we can do it via Swinjack, or in Android, we can do it via Dagger. Yeah. So services in the feature modules just requires to resolve this, and they do not really need to know about the actual implementation or what is actually the database is built for. Basically, they only interact with a resolved instance of a list of APIs to perform the functionalities. So which means that this sets up a programming paradigm. For example, in this case, we have reactive programming. We can expose reactive interfaces through the base layer to the functional calls. And the example here basically says that the feature call requires persistence functionality to the application database, and it is injected through the base Radix layer into the application functional call itself. So if we zoom out and look at the bigger picture, above there, we have some central services, which it can be things like identity or authentication and authorization module, as well as databases, API clients, something that all feature calls would share to be dependency, to be injected via the Radix layer or the base layer, while the feature modules depends on it. So the feature modules here really just need to expose certain UI entry points for the application to actually interact with. So for example, if you can see here, feature module A has 2 entry points, feature module B has 3 entry points, so on and so forth. Entry points can be something like when you click on login button, what happens? That can be a trigger of an entry point. If you can see here at the bottom of the entry points, there's also a layer where you can control different features from different teams to be released or to be controlled over a feature flagging mechanism in the application itself. So each of these entry point, if properly managed under a feature flagging system, we basically can roll out different new functions as well as fixes through a feature flagged mechanism across all teams. So as we zoom out more and more, functional teams really just need to focus on building the domain logic and creating user interfaces. And they actually don't need to care a lot about the common operations and keep reinventing the cycle. So basically, as a feature developer yourself, you will have the chance to work on the product domain logic more than the common operations, like how to write an API client, how to write a database client, for example. And all of that has been done for you. And what you need to do is just to resolve it from the dependency layer. I think as we discuss all of this today, this is something from our experience that works for an enterprise setup where feature teams are actually working on different parts of the application at one time. And this is something that have worked for us. And I hope this helps in giving a bit of idea on some of you may have been having trouble to work across teams. But I would say this is a very specific scenario where you have teams in basically working independently on different features that may not cross each other. And all in all, I think we should keep the engineering as minimum as possible, as simple as possible for everybody to adopt. Do not over-engineer it. I think when, basically like this little cartoon that we see here, we might have a state-of-the-art architecture and every part is reusable, but when we look at the product itself, if it doesn't work, if it doesn't provide the value to the customers, basically is still a failure. So do not over-engineer it, I would say, and pick whatever architecture that suits you best, and hope this sharing helps some of you out there in terms of how to get on top of working across teams. So that's all I have to share today. Thank you very much for staying on with me for the past 20 minutes or so. You can add me on LinkedIn and also Instagram if you want to follow me. Thank you. I'll be here for questions if you have any.